Hi, everybody. What we're going to be studying today will be exponential functions. And as you can see at the top of the paper, exponential functions basically are in the form of y equals b to the x, where b is going to be a positive real number. So the first thing we're going to do is we're going to graph these values so we can get an idea of what exponential functions look like. So we probably don't need our calculator to do the math here. We should be able to do these. So let's first start off with 2 to the 0. We know that anything to the 0 power is 1. 2 squared is 2. I'm sorry, 2 to the first is 2. 2 squared is 4. 2 to the third is 8. That should be simple. 2 to the negative 1, remember, brings that 2 downstairs to the denominator and makes it 1/2. 2 to the negative 2 means 1 over 2 squared, which is 1/4. And 2 to the negative third is 1/8. And hopefully you see a little bit of a pattern emerging here. So let's go ahead and graph our first exponential function. I always like to start here and then kind of work my way. And what you'll notice is it's like slowly going up and then boom, starts going really fast. Okay, and here it's creeping along and it's getting closer and closer to 0, but it's actually never going to quite be 0. So the function looks like this. And that again, like I said, is y equals 2 to the x power. So a couple things I want to point out. We will have an asymptote here at y equals 0. Again, our numbers creep slowly, slowly, slowly up, and then boom, they shoot up really fast. Okay, so now we're going to see what effect adding 3 has to this. And we should already know this because we know how families of functions work. And we know by adding 3, it simply moves everything up 3 units. So we're going to fill this in. And then we can go ahead and graph that. And it should just be 3 units above what we just did. And we get this little optical illusion as if it's getting closer and closer, but it's always going to be exactly 3 units above. Which incidentally means that the asymptote is also 3 units above the other asymptote. So we have an asymptote here at y equals 3. So those are both examples of exponential growth functions. What I would like for you to do is I would like for you to pause this video and then go ahead and do the next problem and then turn the video on so you can make sure that it looks correct. I want you to notice that value inside the parentheses is less than 1. So that's going to have an effect on the graph. Okay, so go ahead and do that in your calculator and let's see how you do. Okay, so how did you do? Hopefully you can see these are both starting with a high value and then dropping as they go to the right, which really indicates that it's an example of exponential decay. Okay, as something shrinks, it's decay. As it grows, it's an example of exponential growth. So it's kind of what we're talking about here. Decay occurs when our base value is between 0 and 1. So you'll see it dropping to the right. Our growth value would be when the base value is bigger than 1 and it grows to the right. And these are lots of different examples of when we would see growth and decay or use growth and decay equations, formulas. So the first example we're going to talk about is when we have a single payment or a single value, and we're looking to figure out how much something is going to be worth or how much is going to be there in a certain amount of time. So we need to know what our variables are. So n represents the new amount. Okay. N sub 0 represents the initial amount. In other words, the amount that you started with. R will be the rate. And what we have to remember is that in order to use an equation, we have to convert the rate from a percent to a decimal by moving that decimal point over 2 places to the left. NT for this equation will be time in years. Okay, important that you know that and that we know that it's going to be in years. So here's a simple example. Notice that it says a car depreciates or loses value at a rate of 20% per year. The car originally cost $20,000. So we need to model the scenario with the decay formula, that's the one we just talked about, where R is depreciation and T is the time in years. So in other words, the value of the car now or after a certain number of years will be $20,000 times 1. And now because it's decay, we will subtract 0.2. Now, where did I get that 0.2 from? Well, 20%, the decimal would have been here. 1, 2 makes it 0.2. And then that's going to be raised to the t value. Now, we can clean that up a little bit. If it's losing 20% of its value, then we can also say that it's retaining 80% of its value, which means in here, 1 minus 0.2 is 0.8. It's a little bit more efficient. And now in section B, it says calculate the value of the car at the end of 2 years. So all we have to do is drop a 2 in here. So I'd like for you to do that in your calculators. You're going to basically put y equals 20,000 times 0.8 to the t, and then pull up your table and you'll be able to go to the 2-year mark, and you should see that the car would be worth $12,800 after 2 years. And you should also be able to look at that table and see how the value of the car is decreasing year after year. Really, really important that you know how to put these in your calculator. Okay, so a little bit more complicated here. We have an equation, and this is a compound interest equation where you have a single payment. Now, compound interest is given not just once a year, it's given a few times a year, and that can change. It can be quarterly, it can be every 6 months, so we just have to really read the problem and make sure we know what's going on. So let's go through our variables. A will be the new amount of money that we're going to have after a certain amount of time. P is what we call the principal, which is the initial amount. It's the amount that you're putting in, okay? So just like in the previous equation, n sub 0 was the initial amount. Well, now we're calling it P for principal because we're dealing with money. R will be the rate, and again, we have to go percent to decimal, just like we did in the previous problem. N, that's a new variable. It will be representing the number of times your money will be compounded yearly. So, for example, if it said you were getting money compounded monthly, that number would be 12. If it was quarterly, that means 4 times a year. If it was semi-annually, that would be 2 times a year. And T is time in years. Okay, so a little bit more complicated. Let's look at our example. So it says, how much should Sabrina invest now in a money market account if she wants to have $9,000 at the end of 10 years? So we're looking for how much money she should put in. Here's what I do off to the side. I try to write everything down. It says 6% compounded quarterly. So first of all, our rate is 6%. Back that decimal up 2 places. We will use 0.6 in our equation. N is the number of times per year she's going to get paid, and it's quarterly, which means 4 times. And T, well, we know she wants to keep that money in there for 10 years. So looking at our equation, we would write our equation like this, and then we'll drop our numbers in. So there's our equation. And I want you to keep in mind, we're trying to figure out P, the principal value. So again, she wants $9,000 in 10 years. She doesn't know how much money she should put in right now, but she does know that she's getting 6% compounded quarterly, and she's going to keep that money in there for 10 years. See, the deal is they don't give you 6% 4 times. They give you a fourth of that 4 times throughout the year. So what you're going to do is you're going to just put this side into your calculator. So I sometimes turn it into a decimal, but you don't have to. If you did turn this into a decimal, only use this when it's exact, which in this case it is. So you're going to put 1.05015 raised to the 40th power in your calculator. When you get that value, you need to do 9,000 divided by that value. And remember, in your calculators, you can do 9,000 divided by the answer key. Make sure I know exactly which one it is. Okay, if you hit second and the negative sign, it says answer. So it will take this exact value and divide it into 9,000. You should get a principal of $4,961.36. And we need to be that precise. So you can't round the value that you get from this because it'll throw the finances off. Okay, so please make sure you got that value in your calculator and you know how to do it. Okay, so we're going to stop there. You're going to do this graphing in your calculator, and you're also going to do the next page for homework, which is the same equation over and over and over again, just looking at different values being put in, okay, and how much money you'll have after a certain amount of time. Have a great day, everybody.